good morning, everyone. I'm Sergio Calamarin, and today I'm going to present my work, Global Mobile Network Aggregators, Taxonomy, Roaming, Performance, and Optimization. This work was being done with Arabin Rahman, Willy Wu, Andra Lutu, Marcelo Bagnulo, Ozwalai, and Fabian Bustamante. So first of all, during the mobile communications evolution, we have seen different types of mobile operators. The first ones were the traditional MNOs, mobile network operators, that by definition, they own or has the exploitation rights of the cellular network. Then, seeing the market opportunity, the mobile virtual networks operators appeared, that they are companies that resell the wireless technology, and they are defined by their lack of ownership of the cellular network. Then they have to use the traditional MNOs to serve to their clients. Lately, the mobile network aggregators appeared, that in difference with the mobile virtual network operators, they can rely in different multiple MNOs, meaning that they can multiplex the clients across different multiple MNOs to ensure the optimal service and to have a good quality of experience. Then we have two differences, the light and full MVNOs and MNAs. Depending on the technological layer that they add over the MNOs, we define light and full. It depends that a full MVNO and a full MNA, they can add their own core network. So we have an increasing roaming demand from different use cases that they come from the smart cars, IoT, and digital nomads. There is an increasing demand to have seamless connectivity across the globe. We can assume that the digital nomads, that they will work abroad and no matter where, they need this global connectivity. But why IoT does need the roaming? Because they are normally static devices. So a company that has a global footprint, if they want to deploy a campaign with our IoT devices around the world, imagine how many operators, contracts, terms, and etc. they have to face with different countries. So the main solution will be to have a single operator that gives the simplicity of having global coverage, having only one kind of SIM card, only one contract, and only one device monitoring. Then, which will be the real performance of one kind of these operators. Then let's describe which are their schemes for providing roaming services. So in this figure, we are representing the different schemes of roaming that we have. So we have the home-routed roaming, the local breakout, and the IPX hub breakout. The home-routed roaming is the one that is the most used for the vast majority of MNOs. But it has a bad performance. Why? Because they have to create a GTP tunnel from the serving gateway of the visited network to the P gateway of the home-routed network and exit to internet from the home country. And we have a bad penalty and delay. But it's the most used because it simplifies the billing, meaning that both operators know which are the resources that the user has used, and then they can charge to the user. The local breakout, it will be a solution because it has less penalty and delay because it uses the serving gateway and the P gateway of the same visited network, but it's more difficult to have billing. Then a solution in between, it could be the IPX hub breakout, that it has a better performance than the home-routed roaming because the exit to the internet, it will be closer to the mobile user. So our contribution is the following. We will measure which is the real impact of global operators in roaming on the end user performance. for Google Fi, Twilio, and Truphone. We have performed 4 different experiments that are the traceroute, DNS resolution delay, web performance, and video performance. And for the convenience of time, I will only talk about traceroute and web performance. So in our experimental setup, we have 5 different subscriptions to 5 different operators that are Orange, 3Network, Google Fi, Truphone, and Twilio. Orange, it's an MNO that operates in Spain, and it will be our baseline, because all the experiments were done in Spain. Then we have 3Network, that is a mobile network operator in Europe, that it will act as a roaming network operator in Spain. Then we have Google Fi, that the definition in our taxonomy says that it's a light MNA, and it has a feature that it has a built-in VPN, that it has some pros and cons. The pros are that they assure reliability, security, and privacy for the connection, but the cons I will explain later. Then they say that you can connect through T-Mobile, US Cellular, Sprint in the US, and 3Network from Europe. But in our experiments, we only see that we were able to connect to internet through T-Mobile and 3Network. Truphone, it's also a light MNA that it operates in 8 base MNOs in different countries. And in Spain, it operates through Orange. Twilio, on the other side, it's a full MNA because it has its own core network in Amazon Web Service Cloud. It targets to IoT devices, and it works over T-Mobile. Also, in our experiments, we target 4 different domains that are UCLA, URL, UC Louvain, and MIT. And for all of these ones, they were geolocated in different positions. In the US, in Spain, in Belgium, and the MIT was working as a CDN. So the software that we use are the following. We use 3 applications of Android, one to measure the traceroute, that this one was an open source that it's in GitHub, and we customized for our needs. The second one we created for the project to measure the DNS and web performance. And the third one is Yomo app, that it was developed by University of Würzburg. So what we did, we measured 20 times for each configuration and for each experiment the 4 different geolocations. So for the traceroute, firstly, on the right table, you have the different configurations that we have and the first hop breakout. You can see that in for example, the configurations of FIG, we have 4 different configurations because we were analyzing FIG with the connection of over 3 with and without VPN, and the connection over T-Mobile with and without VPN. Then on the figure, on the x-axis, we have the hops that we did in the traceroute, and in the y-axis, the delay. And we are only showing the experiment to connect from Spain to Belgium for the 8 different configurations. So for Orange, we see that our first hop is lower than 50 milliseconds, and the last hop is over 50 milliseconds, meaning that we are doing kind of route going away from Spain. Then from 3Network, the first hop, we can see that it's over 50 milliseconds and close to 100, meaning that the first hop is not done in Spain, so it is doing home-routed roaming. And also the last hop, it's closer to 50 milliseconds. Then for Truphone, we see that also we are exiting to internet from Europe, not from Spain, and the last hop is also in 50 milliseconds. Also, here we can say that the breakout in Europe is good enough to don't have delay penalty, because also in the configuration of the 3Network without VPN, we have the same results. But now, here we see a dramatically change when we enable the VPN, meaning that if you compare, we have a huge jump in the first hop meaning that we are now exiting through the US and now coming to Belgium. So the connection is the following: from Spain to the US, to Belgium, to the US, to Spain. So we have a huge penalty in delay. And it happens the same with feed, with Google Fi, with T-Mobile, without VPN, that our first copy is already, even not having VPN, we are doing home-routed roaming. And we have a dramatically experience about penalty. The same happens with the fee with T-Mobile and with VPN. Then with Twilio, we see that also we have the same effect, but in a lower latencies, because also United States is huge, and the Google Fi are exiting in the west coast, and Twilio is in the east coast. So here we have an overall image of the whole picture, and we see that when we have the regional breakout in Spain, in Europe, we don't have such a delay penalty than if we have the home-routed roaming going to the US. Then, for the web performance as well, and we have in the right table the breakouts, and in the left figure, on the x-axis, we have the different configurations. On the y-axis, we measure the page load time, and for each column, it means the different domains that we were targeting. So our baseline is orange, that is here in the middle. And we can see that for US breakout, we have large penalties to accessing EU web pages. For example, to the URL and UC domain. But having regional breakout, namely feed 3 without VPN and TruePhone, we have a close performance to orange, a good enough performance that it does not impact in the end user point of view. Also, if you see in all the configurations, the CDN is the lowest one for each one. But it does not eliminate the difference, the difference in the PLT for each different configuration, meaning that we are accessing to the CDN that is closer to our breakout point. So also in the paper, I have more results about the DNS resolution query, the video performance, and the 5G simulation. But for convenience of time, if you want, we can talk offline. And also, our takeaways are that the current MNOs roaming schemes have a bad performance, performance penalty, and they are difficult to use for new business models and digital nomads. The MNAs have the potential to fulfill those use cases, but nowadays the solutions that we have are not optimal. And the regional breakout, it could be a solution good enough to ensure a reliable performance. And also TruePhone is the one that is closest to an optimal to a local performance, that it could be the baseline. And the applicability for app developers and app providers, it could be that they can be aware of the limitations of the systems and potentially mitigate them. Meaning that if you are doing a streaming app, you knowing which is the network performance, you can do a large buffer in order that the end user does not notice that they have a bad connection. So thank you, and open for questions.